Okay, we want to find the voltage V across this 9 ohm resistor, but we have a dependent source in this circuit here. And in fact, it's a current source and it depends on a voltage over here, so it's a voltage controlled current source. So we're going to need an equation that will allow us to get a number for V1 eventually. So let's see if we can analyze this side of the circuit to get V1. Now, since these two sides of the circuit are kind of isolated, this side from the other, this problem becomes extremely easy. This side of the circuit just looks like a voltage divider. We're given the total voltage. These two are in series. If we do KCL, we want the voltage across one of the resistors. So V1 is the total voltage, 6 volts, times 4 ohms over the sum of the two resistances, 4 ohms plus 2 ohms. That becomes 4 volts. Now I have a number that I can plug in here. So 2 times V1 is 2 times 4. This current source is giving us 8 amps. So now I have a number for that current source and I can treat it as if it's just a number. Now I need to analyze this side of the circuit to find the voltage V. The 9 ohm and 3 ohm resistor are in parallel and I want a voltage across those. It's going to be easy to combine those two to an equivalent resistance. So these two, REQ is going to be 3 ohms times 9 ohms over 3 ohms plus 9 ohms, which becomes 27 over 12 ohms. So now our equivalent circuit is my 8 amp source, this 2 ohm resistor, and this equivalent resistance that is 27 over 12 ohms. Now 8 amps is going this direction, which means that since all of these are in series, this is an 8 amp current in that direction. I'm going to choose my voltage polarity such that this is a positive current. So let me call this V sub x. 8 amps is entering the positive terminal, so this just becomes, by Ohm's law, 8 amps times 27 over 12 ohms. So V sub x is, let's see, 8 over 12 is 2/3 times 27 is 2 times 9, or 18 volts. But V sub x has the opposite polarity as that defined for V, so V is just equal to minus V sub x, which is negative 18 volts. Now, as usual, there's more than one way to do a problem. Let me recalculate the voltage V here, and I think I'll use nodal analysis. So I still have my 8 amp source, have a 2 ohm resistor, I have a 3 ohm resistor, I have a 9 ohm resistor, and this is V. I'm going to define this as my reference node, 0 volts. I'm going to define this as my unknown voltage V sub A. I only have one independent node. So KCL here says that 8 amps is leaving, plus the current through the 3 ohm resistor is V sub A minus 0 volts over 3 ohms, plus VA minus 0 volts over 9 ohms is the current through the 9 ohm resistor. So if I multiply through by 9, I get 8 times 9, which is 72 volts, plus 3 VA plus VA is equal to 0. So 4 VA is equal to minus 72 volts, and VA 72 over 4 is 18, is minus 18 volts, and I get the same answer as I got before, which is pretty comforting because it shouldn't matter how I analyze the circuit as long as I don't analyze it wrong.